At the heart of existence lies a paradox. The universe did not begin in quiet order, but in collapse. Not the collapse of ruin, but of creation, a fall that gave birth to everything in the silence before time. A primordial field may have stretched across reality, smooth and uniform, heavy with potential. For an immeasurable instant, it held. Then, like a stone finally breaking free from the cliff's edge, it faltered. It collapsed. From that collapse came fire, an eruption of unimaginable expansion, space itself swelling faster than light, energy boiling into matter, the seeds of galaxies carried outward on an ocean of inflation. What we call the Big Bang may not have been a beginning, but the aftermath of a fall. Yet collapse is never singular. In physics, when a field tips from one state into another, it does not do so uniformly. It crumples in patches, fractures into regions, each collapse carrying its own destiny. If this is true, then our universe is not alone. It is one bubble among countless others, born from a chain of collapses that ripple across an endless fabric. Each universe shaped by its own fall, each carrying different laws, different stories. Different stars dot the cosmos we see may be nothing more than one page in an eternal library, a single thread woven into a tapestry too vast to grasp. And so the haunting question rises. Was it the collapse of the primordial field that not only shaped our universe, but opened the door to the multiverse itself? The story of the collapse begins, not in the void before time, but in the quiet rooms of human thought, with scientists staring upward, questioning what the universe truly was. Einstein and the Shaping of Space in 1915. Albert Einstein unveiled the general theory of relativity. Space and time, once thought of as separate absolutes, were joined into a single fabric, space-time. This fabric was not rigid, but pliant, bending under the weight of mass and energy. Gravity was no longer a force acting at a distance. It was geometry itself, the curving of the cosmos around stars, planets, and galaxies. Einstein believed the universe must be eternal and static. To preserve this vision, he introduced the cosmological constant, a balancing term to prevent collapse. Yet in doing so, he unknowingly foreshadowed a force that modern science now calls dark energy. Hubble and the expanding universe in the 1920s. Edwin Hubble, working with the 100-inch Hooker telescope on Mount Wilson, made a discovery that shattered Einstein's vision. Galaxies, he observed, were not fixed. Their light was redshifted, stretched as if carried away by an expanding cosmos. The universe was not static. It was dynamic, swelling outward like a balloon. If it was expanding now, then at some earlier time it must have been smaller, denser, hotter. This realization gave birth to the idea of the Big Bang, a universe born in a moment of explosive creation, the puzzles of the Big Bang. Yet the Big Bang alone raised unsettling questions. Why was the universe so smooth, so uniform in all directions? Why did regions of space, separated by billions of light years, share the same temperature, when there had not been enough time for light to pass between them? And why was the geometry of the cosmos so finely balanced, resting on the knife edge between collapse and eternal expansion? The Big Bang model alone could not answer. A deeper mechanism was needed. The birth of inflation in the early 1980s. Physicist Alan Guth proposed a radical solution. Perhaps in the first instant after the Big Bang, the universe underwent a period of hyperexpansion, inflation. Driven by a high-energy quantum field, space itself ballooned exponentially. doubling in size again and again in less than a fraction of a second. Inflation explained the puzzles. It smoothed the cosmos, ironing out irregularities. It pushed regions of space far beyond each other's horizons, yet imprinted them with the same primordial conditions. It balanced the universe's geometry, flattening it on cosmic scales. But inflation was not eternal. It ended in collapse. As the inflationary fields lost stability, it tumbled into a lower energy state. The energy of that fall released itself as matter, radiation, and particles. The universe ignited. What we call the Big Bang may have been not the birth itself, but the aftershock of this collapse, the energy of a field shattering into stars, galaxies, and life. The fingerprints of collapse. If inflation was true, then evidence of the collapse should linger. In 1992, the COBE satellite revealed tiny fluctuations in the cosmic microwave background, relic radiation from the young universe. These fluctuations matched predictions, quantum jitters in the inflationary field, magnified to cosmic scale, seeding galaxies and clusters. Later, the WMAP and Planck satellites refined the picture, mapping the cosmic background with exquisite precision. The fingerprints of inflation appeared undeniable. The collapse had left its mark. The deeper mystery emerges yet in solving one puzzle, inflation revealed another. For if a field could collapse once, birthing our universe, could it collapse again elsewhere? Could inflation continue in other regions of space-time, still bubbling outward, still tumbling into new universes with each fall? Physicists began to suspect that inflation was not a singular event, but a perpetual process, eternal inflation. In this vision, collapse does not end creation, it sustains it. Each collapse seeds a new universe with its own Big Bang, its own stars, its own destiny. Our cosmos, then, may be one bubble in an infinite foam, one outcome in a multiverse shaped by collapse. The central question, from Einstein's equations to Hubble's redshifts to Guth's inflation. The story of the cosmos grew from static to dynamic, from singular to plural. What began as a quest to understand one universe unfolded into a suspicion of many. The collapse of the inflationary field did more than ignite the Big Bang. It raised the possibility that collapse itself is the architect of all realities, and so the central question sharpened: was our universe a unique creation, or one among countless others, born from an eternal cascade of collapses that shaped the multiverse? The theory of inflation, born in the early 1980s, was meant to solve puzzles. It smoothed the wrinkles of the Big Bang, balanced the geometry of the cosmos, and explained how galaxies were seeded from quantum fluctuations. But the solution carried with it a revelation so vast, so disquieting, that it shook the very foundations of science. The consequence of inflation is not a gentle process. It does not stop neatly at one time, in one place. The mathematics suggests that while inflation may have ended here, in the bubble of space we call our universe, it may not have ended everywhere. Quantum fields fluctuate. In some regions, inflation collapses swiftly, releasing energy into matter and radiation, birthing stars and galaxies. In others, the field lingers, space still stretching, still inflating. And within those inflating regions, new collapses occur, new bubbles form, each igniting its own universe. This is not speculation added after the fact. It is a direct, unavoidable implication of the theory itself. The inflation that created our universe may still be happening, endlessly, eternally, birthing other universes beyond our horizon. A multiverse of collapses. The vision that emerges is staggering. Our universe is not the cosmos entire. It is one bubble in a cosmic foam, a single drop in an endless sea. Each bubble is born from collapse, the fall of an inflationary field into a new state, releasing new energy, new physics. And here lies the shock. Each universe may have different laws. The constants of nature we take as universal. The charge of the electron, the strength of gravity, the speed of light, may be only local conditions. In another bubble, gravity might be weaker, or matter unstable. Stars may never form, or they may burn brighter, shorter, fiercer. Most universes would be barren. A few might carry the delicate balance that permits life, the fine-tuning problem for decades. Scientists have marveled at the fine-tuning of our cosmos. If the strength of the strong nuclear force were even slightly different, atoms could not form. If the cosmological constant were larger, galaxies would never coalesce. If it were smaller, the universe might collapse in on itself. Why does the universe permit life? Why do the laws fall in the narrow window where complexity and consciousness can arise? The multiverse, born from endless collapse, offers one possible answer. Perhaps there are not one set of laws, but countless. We live in a universe tuned for life, not because it was destined, but because, in an infinity of collapses, some universes inevitably fall into life's narrow range. We exist because we are in one of those rare bubbles. This is the anthropic principle, unsettling, controversial, but unavoidable once the multiverse is considered. The shattering of uniqueness for centuries. Humanity has sought to believe the universe is singular. Copernicus stripped Earth of its central place, but the cosmos remained one. Now, inflation threatened even that. Our universe may not be unique. It may not even be special. It is one among countless others. It's apparent. Order born not from inevitability, but from chance to many. This was exhilarating. A cosmos larger than imagination, rich with possibilities. To others, it was devastating. If other universes are forever beyond observation, then how can physics prove them? Does the multiverse lie beyond the reach of science, drifting into philosophy or metaphysics? This was the true shock. Not only did inflation suggest infinite universes, it challenged the very boundary of what science could claim to know. The philosophical Riftenstein once resisted the randomness of quantum mechanics, declaring that God does not play dice. The multiverse pushed the argument further. What if reality itself is dice thrown on the grandest scale? What if the laws of physics are not absolute, but accidents of collapse, chosen at random in each bubble of creation? Some physicists they argued that if other universes can never be observed, then the multiverse is not science, but speculation. Others countered that its predictions, the distribution of cosmic microwave background fluctuations, the flatness of the universe, the seeds of galaxies, had already been borne out. The multiverse was not a theory apart from inflation. It was the consequence inflation demanded. The scientific community split, exhilarated, and unsettled in equal measure. The human shock for the human mind, trained to seek certainty. The multiverse is a dizzying concept. It suggests that what we call reality is not the whole, but only one thread in an endless fabric. That our universe's birth was not the beginning, but one of infinite beginnings. And it suggests something even stranger. That collapse is not an end, but a constant rhythm of creation. The inflationary field collapses here, birthing our universe. It collapses again elsewhere, birthing another. The multiverse grows, not from expansion, but from fall, from instability, from collapse that endlessly seeds new reality. The collapse and the question, the shock of this revelation was not just scientific, it was existential. If our universe is not unique, then what are we? If other worlds exist, forever beyond our reach, does our search for ultimate truth falter? Or does it expand, recognizing that truth itself may be infinite, layered, without final foundation? The collapse that birthed our universe may not have been a singular moment of creation, but part of an eternal cascade. And with that realization came a profound unease. The universe was larger than we had ever believed, and the collapse that shaped it was not the end of mystery, but the beginning of an infinite one. The shock of eternal inflation left physics suspended between awe and unease. If collapse is not singular but eternal, then evidence of its traces must exist, not in imagined worlds, but in the universe we see. And so the search began. Scientists turned to the sky, to radiation older than stars, to particles that slip ghost-like through matter, and to the trembling fabric of space-time itself. Each tool was a probe, reaching for the fingerprints of collapse, the relic light of creation. The most direct witness to our universe's birth is the cosmic microwave background, the faint afterglow of the Big Bang, born when the cosmos was just 380,000 years old. It is the oldest light we can observe, stretched and cooled to microwaves by billions of years of expansion. In the early 1990s, the COBE satellite first mapped this relic light, revealing it to be astonishingly smooth. The same temperature in every direction. But embedded in that smoothness were tiny ripples, fluctuations in temperature 1 part in 100,000. These imperfections were not random. They were the imprints of quantum fluctuations in the inflationary field, magnified to cosmic scales during collapse. Later, missions, WMAP, and then Planck sharpened the image with breathtaking precision. What emerged was a detailed portrait of the universe's infancy, the distribution of galaxies, the clustering of matter, even the fate of cosmic expansion. All could be traced to these primordial ripples. Inflation's fingerprints were clear. The collapse had left scars that could still be read in the heavens. The cold spot and cosmic anomalies, yet amid the clarity, anomalies appeared. The Planck satellite revealed a vast region of the microwave background cooler than its the so-called cold spot. Too large, too unlikely to have formed by chance. Some suggested it might be the mark of a collision, the bruising of our universe against another bubble in the multiverse. Other alignments, dubbed the axis of evil, hinted at large-scale structures inconsistent with pure randomness. Were these statistical flukes, or subtle evidence of physics beyond our universe, shadows of other collapses imprinted on our sky? No consensus exists, but the anomalies remain, beckoning with the possibility that our cosmos has neighbors, other universes brushing against our own. The language of particles while telescopes scanned the sky. Particle physics looked inward to the quantum foundations of collapse. The Higgs field, confirmed in 2012, revealed that even empty space is not empty but structured. Particles gain mass by interacting with this invisible field. But the Higgs mass also hinted at something unsettling. Our universe may not be in its most stable state. If the vacuum we inhabit is false, then collapse is not finished. One day, the vacuum could decay, a bubble of lower energy expanding at the speed of light, rewriting the laws of physics as it passes. This idea, called vacuum metastability, links the birth of our universe to its possible death, both outcomes of collapse. It ties the smallest particles to the largest questions, suggesting that what began the cosmos may one day end it. Quantum fluctuations, as architect's inflation, did more than smooth the cosmos. It amplified the tiniest quantum fluctuations into the scaffolding of galaxies. Without collapse, there would be no structure, no stars, no life. This revelation reframed randomness itself. The noise of quantum uncertainty was not a bug, but the blueprint of creation. Probability became architecture. Possibility became existence. And if fluctuations built our universe, might they also seed others? Each collapse of the inflationary field could magnify different fluctuations, shaping universes with radically different structures. The multiverse, then, is not just possible, it is inevitable, born from the very fabric of quantum mechanics. The false vacuum question physicists turned to calculations, examining whether our universe is truly stable. The results were ambiguous. The Higgs boson's mass suggested our vacuum teeters on the edge, long-lived, but not eternal. If correct, then collapse is not only the past of the universe, but also its potential future. Just as inflation's collapse birthed our cosmos, so too might a future collapse erase it. The multiverse is not only behind us, it may lie ahead. The hunt for gravitational echoes, another frontier lies in gravitational waves, ripples in space-time itself. In 2015, LIGO detected the merger of black holes, opening a new era of astronomy. But scientists hope to find something older, primordial gravitational waves, faint tremors from the collapse of inflation. If detected, these waves would be direct evidence of inflation, vibrations from the very moment the field fell and ignited our cosmos. Future missions, like the space-based LISO observatory, aim to listen for these whispers. If heard, they would be the music of creation itself, proof that collapse shaped not only our universe, but the multiverse beyond, the deepening mystery. Discovery has clarified and complicated in equal measure. The CMB revealed inflation's fingerprints, but also anomalies hinting at other universes. The Higgs confirmed the existence of fields, but also raised the specter of vacuum decay. Gravitational waves opened a new window, but left us listening for echoes still unheard. The deeper we investigate, the clearer the paradox becomes. Collapse explains everything, and yet opens to infinities that may never be observed. The question that remains: did our universe's collapse happen once or endlessly? Are we the singular child of a primordial fall, or one of countless offspring scattered across the multiverse? The data speaks in fragments, like pieces of a shattered mirror. Each reflection shows part of the truth, but never the whole. What is certain is that collapse is no longer just destruction. It is the central act of creation, the moment that shapes universes, the rhythm that may extend forever. The deeper scientists probed the evidence, the clearer it became that collapse was not a singular event. It was not the unique birth of one cosmos, but a process ongoing, endless, terrifying in its implications. What began as an elegant solution to the puzzles of the Big Bang unfolded into a vision of infinite creation, infinite destruction, infinite uncertainty, eternal inflation, creation without end. The mathematics of inflation carried a consequence too immense to ignore. Inflation, once triggered, does not stop everywhere at once. In some patches, collapse occurs, releasing matter and light, birthing universes like ours. But elsewhere, the field continues to inflate, stretching space at superluminal speeds. This process never ends. While some regions collapse, others expand, driving inflation forward. Each collapse creates a bubble universe, sealed from the others by horizons forever unreachable. The result is eternal inflation, a cosmos not of one universe, but of countless, budding endlessly, each born from collapse. Our own universe is not the rule, but the exception. Creation becomes perpetual. Collapse becomes the architect of infinity, the fear of fragility. False vacuum, decayed eternal creation carries a darker reflection. If our universe itself rests in a false vacuum, a temporary plateau of energy, rather than the lowest possible state, then collapse is not only in our past, but in our future. A single quantum fluctuation could trigger the decay, birthing a bubble of true vacuum. This bubble would expand at nearly the speed of light, erasing everything it touches, rewriting the laws of physics in its wake. No warning, no defense, no escape. The universe we know, with its stars and galaxies, its chemistry and life, could vanish in an instant, replaced by a cosmos utterly alien. The possibility is remote, but not fantasy. Calculations using the Higgs boson's mass suggest that our universe may indeed be metastable. The ground of reality trembles beneath us, even as we walk across it. Entanglement on a cosmic scale as collapse grew darker in its implications. Quantum mechanics added another layer of strangeness. Entanglement revealed that particles could share states across vast distances, linked instantly, no matter the space between them. What if collapse itself, the fall of fields, the branching of wave functions, is entangled across universes? What if the fates of bubbles in the multiverse are not isolated, but bound together in ways we cannot yet conceive? The idea is speculative, but the mathematics hints at it. The same laws that link photons across laboratories may link entire universes, across infinity. The multiverse may not be a foam of isolated bubbles, but a web, a lattice of futures tied together by collapse. The collapse as cosmic rhythm, this vision. Collapse is no longer rare, no longer singular. It becomes rhythm. Inflation collapses here, birthing one universe. It lingers there, birthing another. In one region, a false vacuum decays, erasing a cosmos. In another, collapse seeds galaxies from quantum fluctuations. Collapse becomes the heartbeat of reality, the pulse by which the multiverse breathes. Each collapse both ends and begins. Each collapse is death and birth intertwined. The terror of no final foundation for centuries. Science has sought foundations, the bedrock of reality, the ultimate law. But collapse suggests that there may be no foundation at all, only endless layers of possibility. Inflation collapses into universes. Vacuums collapse into lower states. Wave functions collapse into outcomes. And beneath each collapse lies another, deeper field, another potential fall. The more we search, the more reality seems to recede, like a horizon never reached. The universe is not built upon certainty, but upon instability, collapse feeding collapse without end. This is the deepest terror, that physics may never arrive at a final answer, that each solution will only reveal another layer of fragility, another abyss of possibility. The human reflection. What does it mean to live in such a cosmos? A universe born of collapse, fragile with the threat of collapse, surrounded by countless universes birthed from collapses we will never see. It means that existence itself is precarious, that the stability we take for granted, the stars above, the laws of physics, the beating of a heart, rests on trembling foundations. Yet fragility gives weight to life. To know that collapse could erase everything is to recognize the preciousness of each moment. The finite becomes luminous against the backdrop of infinity. The escalation of mystery, the story of collapse, began as a scientific hypothesis, a mechanism to explain puzzles in the Big Bang. It has become something larger, something stranger, something more unsettling. Collapse is no longer simply the trigger of one creation. It is the engine of endless creation, endless destruction, endless uncertainty. It is the rhythm of the multiverse, the silent force that shapes not one reality, but countless. And in that recognition, the mystery deepens. For if collapse is the heartbeat of the cosmos, then the question is not whether it happened once, but whether it will ever end. The deeper collapse was studied, the more it became clear that its meaning stretched beyond observation. The cosmos seemed to demand not one interpretation, but many, each bold, each incomplete, each shimmering with possibility. The collapse that shaped our universe may also shape every theory we build, forcing science to imagine realities stranger than imagination itself. Eternal inflation. An endless cascade. The first and most direct speculation is the natural extension of inflation itself. If inflation ended here, birthing our cosmos, why should it end everywhere? The mathematics resists closure. Regions of the field may collapse into universes like ours, while others continue expanding, their energy untouched, their inflation eternal. In this picture, collapse is not rare but constant, the engine of an infinite cascade. Every collapse births a new universe, each bubble sealed from the rest, each carrying its own Big Bang. Our cosmos becomes a single droplet in a storm without end. This speculation is not embellishment. It is the logical consequence of equations, and yet its implications are so vast that they blur the line between science and philosophy. False, vacuum decay, collapse, as doomed the discovery of the Higgs boson, raised a darker possibility. If our universe is not resting in the lowest possible energy state, then the vacuum itself is unstable. We may inhabit a false vacuum, long-lived but fragile. Collapse, then, is not only our past but our fate. A quantum fluctuation could trigger decay, birthing a bubble of lower energy that expands at the speed of light, erasing everything. This collapse would not seed galaxies or stars. It would extinguish them. False vacuum decay transforms collapse into an existential threat, the ultimate fragility of existence, hidden in the structure of fields themselves. The quantum multiverse, collapse of wave functions. Quant mechanics adds another layer. Each particle exists in superposition, a haze of possibilities described by its wave function. Only when observed does it collapse into a definite state. One interpretation, the many worlds hypothesis, denies that collapse discards possibilities. Instead, each outcome is realized, branching into its own universe. A photon goes left in one cosmos, right in another. A star explodes in one branch, collapses silently in another. Every possibility is played out. Every future is real. In this vision, collapse does not narrow futures. It multiplies them, splitting reality into an endless branching tree. The multiverse becomes not only cosmic, but quantum, the branching of wave functions mirrored on universal scales. The string theory landscape, infinite vacuous string theory, humanity's boldest attempt to unify quantum mechanics and relativity, brings its own speculation. In this framework, particles are vibrations of tiny strings, their harmonies giving rise to forces and matter. But string theory does not predict one universe. It predicts a vast landscape of possible vacua, billions, perhaps trillions, of possible energy states, each with its own physics. Collapse, in this vision, becomes selection. Each universe emerges as the inflationary field tumbles into one of these countless valleys. Some universes are barren, their constants hostile to complexity. A rare few, like ours, permit chemistry, stars, and life. The multiverse here is not only endless in number, but endlessly varied in form. Collapse sculpts each cosmos from the raw potential of the string landscape. The anthropic principle, a universe that permits us the fine-tuning of our universe, the delicate balance of constants. That permit life has long puzzled science. Why should gravity, electromagnetism, or the cosmological constant take precisely the values they do? The multiverse provides one answer. If collapse births countless universes with different laws, then most will be sterile. A few will allow complexity. We live in such a universe because only such universes can give rise to observers who ask the question. This is the anthropic principle, not a law of necessity, but a recognition of selection. Collapse creates many futures, but only some include us. The holographic multiverse, reality as information, other speculations push further still. The holographic principle, born from black hole physics, suggests that reality itself may be encoded on surfaces, like a hologram projecting three-dimensional images. If true, then our universe may be only a projection, one of countless encodings of deeper information. In this view, collapse is not the fall of a field, but the reconfiguration of data. The multiverse becomes an ocean of information fields, each collapse rearranging the code into a new cosmos. Cyclic collapse, universes without beginning or end. Some theories imagine collapse not as a one-time event, but as a cycle. Universes expand, cool, and collapse, giving birth to new ones in endless succession. Time itself becomes cyclical, each collapse the death of one reality and the birth of another. In this vision, the multiverse is not an infinite foam of bubbles, but a rhythm of rebirth. Collapse becomes heartbeat, not catastrophe. The convergence of speculations, though these speculations differ: eternal inflation, false vacuum decay, quantum branching, string landscapes, holographic codes, cyclic rebirth. They share one unifying theme. Collapse is not destruction. It is the primal act, the mechanism through which potential becomes actual, through which futures are born. Each theory sees collapse as fundamental. Each recognizes that the universe we inhabit is not inevitable, but contingent, shaped by fields, by chance, by instability, and each leaves us with the same haunting realization. Reality is larger than we can see, larger than we can prove, perhaps larger than we can ever know. The mystery that remains speculation does not end mystery. It deepens it. For if collapse shapes the multiverse, then what shaped collapse? What lies beneath the fields themselves? Is there an ultimate framework, or only endless layers of instability, forever falling, forever birthing? Science has no answer. Only metaphors remain. Collapse as domino, collapse as heartbeat, collapse as the spark that lights infinite fires. Across the void, theories stretch imagination, but they do not close the question. They only remind us that the multiverse may not be fantasy, but the natural consequence of collapse. The theories of collapse and the multiverse stretch the imagination. They demand frameworks of eternal inflation, false vacuum, quantum branching, and infinite landscapes. Yet science is not built on imagination alone. It seeks fingerprints, data, signals written into the cosmos itself. To test collapse, physicists have built machines that span continents, telescopes that gaze back to the dawn of time, and detectors so sensitive they can hear the trembling of space-time. These instruments may not reveal the whole of the multiverse, but they can reveal the traces of collapse, the scars left in our universe by the fall that birthed it, the relic light, cosmic microwave background. The most direct evidence of inflation's collapse comes from the cosmic microwave background, the relic glow of the Big Bang. Satellites like COBE, WMAP, and Planck have mapped its faint radiation with astonishing precision. The tiny fluctuations they reveal are not random noise. They are the amplified whispers of quantum fluctuations, stretched by inflation, frozen into the fabric of the universe. The collapse that ended inflation wrote its memory here, in ripples of temperature across the sky. Scientists search these maps for anomalies, cold spots, alignments, patterns that might betray collisions with other universes. Though the evidence remains uncertain, the possibility lingers that our sky carries shadows of collapses beyond our own. Large-scale surveys, the architecture of galaxies in grander scales, surveys like the Sloan Digital Sky Survey and the upcoming Virasi-Rubin Observatory map billions of galaxies. Their distribution is not random. It reflects the seeds planted by fluctuations in the inflationary field. By tracing this structure, cosmologists test inflation's predictions. The clustering of galaxies, the voids between them, the cosmic web itself, all are evidence of collapse shaping reality on scales beyond imagination. Future surveys, such as ESA's Euclid mission and NASA's Nancy Grace Roman Space Telescope, will map dark energy and cosmic expansion with unprecedented clarity. They may yet reveal whether our universe's acceleration is the mark of a deeper field, or the echo of collapse still unfolding. Gravitational waves, the music of collapse in 2015. The Laser Interferometer Gravitational Wave Observatory, LIGO detected ripples in space-time from colliding black holes. It was the first time humanity had listened to the universe, but physicists hope to hear something older still, primordial gravitational waves, faint vibrations from the collapse of inflation itself. These waves would carry direct evidence of the moment our universe was born, signals untouched since the first instant of time. Experiments like BICEP at the South Pole have searched the polarization of the cosmic microwave background for signs of these waves. Though no definitive signal has yet been found, the quest continues. Future missions, such as the space-based LISA Observatory, will listen to the deep bass notes of the cosmos, perhaps detecting the original echoes of collapse. Particle accelerators, probing the vacuum beneath the border of Switzerland and France. The Large Hadron Collider smashes protons together at energies unseen since the early universe. In 2012, it confirmed the Higgs boson, the particle linked to the Higgs field. But the Higgs also raised the question of metastability, whether our vacuum is truly stable, or perched precariously in a false state. By measuring the Higgs with ever greater precision, physicists hope to know whether collapse is in our past alone, or in our future as well. The collider also searches for hints of new fields, supersymmetric particles, or forces that could explain dark matter, each discovery a potential clue to the deeper architecture of collapse. Dark energy surveys, the expanding mystery in the late 1990s, Astronomers discovered that the universe's expansion is accelerating, driven by a mysterious dark energy. Is this force linked to vacuum energy? Is it a sign of another field at work, still shaping the cosmos long after inflation's collapse? Projects like DESI, the Dark Energy Spectroscopic Instrument, and surveys from the Rubin Observatory aim to trace this acceleration across billions of years. Their goal, to reveal whether dark energy is constant or whether it evolves, hinting at collapses still to come. Quantum experiments, the collapse of possibility in laboratories, physicists probe collapse on the smallest scales. Quantum computing experiments hold particles in superposition, testing how and when wave functions collapse. Entanglement is stretched across kilometers, probing whether distance or time can sever the quantum link. Some propose that gravity itself may cause wave function collapse, linking the quantum to the cosmic. If true, then the collapse of fields in the early universe may be mirrored in every quantum decision, every branching of possibility. Here, the search for the multiverse merges with the study of single particles collapse as the unifying rhythm of all scales. Future frontiers, the next decades, promise even greater tools. Next generation CMB observatories will map relic radiation with unmatched precision. The Rubin Observatory will scan the sky nightly, tracing billions of galaxies. The LISA mission will open a new era of gravitational wave astronomy, listening for whispers of inflation. Proposed colliders, larger than the LHC, will probe fields at energies far beyond today's reach. Each is a probe aimed at the silence of collapse, searching for its hidden fingerprints. The limits of testing, yet even as instruments grow, limits remain. If other universes exist, sealed beyond cosmic horizons, their light will never reach us. If collapse continues elsewhere, we may see only its faintest echoes. Some argue the multiverse may never be testable in full. But even so, science presses forward, not to prove infinity, but to understand the collapse that gave us this one universe, and to search for signs of others brushing against our own. The human mirror. The tools of science are vast, but their purpose is intimate. To study collapse is not only to know the cosmos, it is to know ourselves, fragile beings in a universe born of instability, searching the skies for evidence of other worlds we will never touch. The machines we build, colliders, telescopes, detectors are extensions of our longing, instruments not only of measurement but of wonder. Each map of galaxies, each detection of waves, each signal from particles is a question whispered to the field that shaped us. What are we? What else is there? And sometimes the universe answers. The story of collapse begins in physics, in equations that describe fields and energies. But it does not end there. It spills into philosophy, into questions of meaning, into the quiet spaces of human reflection. For if collapse shaped not only our universe, but the multiverse, then its implications touch everything: existence, freedom, destiny, and the fragile beauty of life itself. A cosmos of many. If collapse is the architect of universes, then ours is not singular. It is one among countless others, each born from a fall of the inflationary field, each carrying its own laws, its own possibilities. In some, stars may never ignite. In others, gravity may crush all into eternal silence. In rare few, the delicate balance of forces permits chemistry, planets, and life. Our universe is not inevitable. It is contingent, the outcome of collapse, choosing one path among many. And in that recognition lies both humility and wonder. We are not the center, we are not the only. Yet we are here, witnesses to a cosmos that permits us, born in a universe fragile and improbable. The question of free will collapse also echoes in philosophy's oldest debate. The question of freedom. If the multiverse exists, then every possibility may be realized somewhere. Every choice is made, every path followed, every outcome lived. In that vision, choice becomes an illusion. The collapse of fields, the branching of wave functions, the endless cascade of universes. All possibilities happen, but another interpretation is possible. Perhaps collapse is real selection, the narrowing of futures into one present. Perhaps each moment of awareness is participation in the act of collapse. Consciousness collapsing possibility into reality. In this light, free will is not erased, it is enshrined. We are the agents through which the universe chooses one path. Through the multiverse, the fragility of existence, the possibility of a false vacuum, decay adds urgency to reflection. If collapse can erase as easily as it creates, then existence is fragile beyond measure. The laws of physics we take for granted may be temporary, the cosmos itself may be temporary, and yet fragility is not despair. It is a call to meaning. To know that collapse could erase everything is to see each moment as luminous, each life as irreplaceable, each connection as infinitely precious. The knowledge of impermanence deepens the beauty of existence. The paradox of collapse. Collapse is paradox. It destroys and it creates. It ends and it begins. It is catastrophe and genesis intertwined. In the multiverse, collapse is heartbeat, a rhythm that never ceases, a falling that endlessly builds. Our universe exists because a field fell. Countless others exist because countless other fields fell. The end of one state becomes the beginning of another. Perhaps this is the deepest lesson. Collapse is not failure. Collapse is the way reality grows. The human mirror, the search for collapse mirrors the human condition. We live lives shaped by endings and beginnings, by collapses of possibility into choice, of time into memory. Each moment is a narrowing of futures into one reality, just as the universe itself narrowed from possibility into existence. To study collapse is to study ourselves. Our longing to understand is itself a reflection of the cosmos, consciousness, reaching back toward its origins, asking what it means to be, the infinite library. Imagine the multiverse as an eternal library. Each collapse writes a new book. Some books are short, universes collapsing swiftly into silence. Others stretch across billions of years, filled with galaxies, stars, and life. Our universe is one volume among infinite shelves, one story among countless others. We cannot read the other books. Their pages are sealed beyond our horizon. Yet we know they exist, written in the mathematics of collapse, hinted in the patterns of our sky. And this realization does not diminish our story. It enriches it. For in an infinite library, each book is unique, each story unrepeatable. Our universe is one such story, fragile and luminous, precious precisely because it will not be written again. The final silence, one day collapse, may come again. The false vacuum may fall. The expansion may accelerate into emptiness. The stars may fade and the cosmos grow cold. But collapse is not the end. It is transition. Just as the collapse of the inflationary field birthed our universe, so too may future collapses birth new ones. The silence of one cosmos may be the overture of another dot in this rhythm of fall and birth. Death and creation lies a beauty beyond. despair. Reality is not static. It is alive, trembling, unstable, always becoming. The last reflection, the collapse that shaped the multiverse, is more than a scientific hypothesis. It is a philosophy written in physics, a mirror held to existence. It tells us that nothing is final, that all is fragile, that possibility is richer than certainty. It asks us to see ourselves not as isolated beings in a single universe, but as participants in a grander story, a story where collapse is the heartbeats of creation, where infinity is the canvas, and where each moment of existence is a miracle born from instability. Look again at the stars. They flicker not as isolated fires, but as echoes of collapses beyond counting, as whispers of universes unseen. They shine because collapse gave them birth, because instability seeded light, because possibility became real, and in their light, the haunting question lingers. If collapse shaped the multiverse before us, what collapse still awaits beyond us? And what new cosmos will be born when our own fall comes?